Okay, it is now 2:30, so let's go ahead and get the show on the road. So, hi, welcome to the 2024 Esri Developer Summit, and you are about to witness the technical session called Strategies for Scripting and Automating. So if that's not where you want to be, you are in the wrong room. I'm going to turn it over and let my colleague Nick introduce himself.
Hi, I'm Nick. I'm a product manager at Esri. I work with a lot of our different spatial analysis and data science products.
And my name is products. Right?
Yes.
My name is John Yaste, and I am a product engineer with the API for Python team. So today, what we're going to talk to you about are strategies for scripting and automating, focusing on Python. And before I get started, I want to let you know that the slides, the notebooks, the materials you see here will be available to you shortly after the conference, within a couple weeks. So in addition to the proceeding site, the Python API team has a repository on GitHub, a public repository at github.com/esri/ArcGIS-Python-API. So I'm going to show you, once you get out there, this is that website. You click on this branch button, start to type the word conference, spell it right, and you'll see a branch come up called Conference Talks. When you click on that, it will take you to a screen that will show you a directory called Talks. In there is a list of many different conferences that we have presented at, and there are materials in notebook slides, materials in all these directories. Within the next couple weeks, there will be a Dev Summit 2024 directory where these materials and those from other sessions at the conference will be available to you. So on we go. Our agenda today, what we're going to do is I'm going to give you a brief introduction to a little bit about why Python is so prevalent in the ArcGIS platform, and then we're just going to launch out into some demos, showing some different ways to script and automate using Python within the platform. And then we'll wrap things up and show you some places you can go for a couple different resources to learn some more information. So why Python? Why is it all over ArcGIS, and why do I care? Right? I think there's a couple different reasons why it's become sort of the scripting language of choice within the platform. Python itself has a huge set of libraries for scientific computing. Experts have written modules covering every topic under the sun. In addition to that, there are management packages within Python for taking care of your packages so that you are able to distribute your scripts and/or applications. There are automated ways and packages that are dedicated to managing those resources for you. And it allows you to run in computing environments, a set of libraries and dependencies that are isolated from other libraries and sets of dependencies. Another reason why Python is so popular across the platform is there's a lot of consistency. When you see Python, you know it. And particularly within the ArcGIS platform, if you know, you see it, a component in one product, and you access Python and use it, you're going to recognize that same kind of component in other products across the platform. There's a real consistency to what Python looks and feels like across all the different products. And it doesn't matter where you're running it. Python looks and behaves the same way. It's platform agnostic, doesn't care if you're on Linux, Windows, or Mac. Right? So what this allowed for is a huge proliferation of domain experts creating code, right, without having to be super hardcore developers. Right? You could get done what you needed to get done in a relatively quick time frame, and no matter what your skill level, you could start producing things that other people could use in your field. Within the platform, there's two libraries where Python is delivered to you. There's ArcPy, and there is the API for Python, or the Python API. These are different libraries, fundamentally designed to accomplish different tasks. ArcPy is kind of the flagship site package for Python that shipped with the desktop platform. So in the previous ArcMap, ArcCatalog, ArcToolbox world, ArcPy was introduced, and it allowed you to work with and manage your map documents and all your file-based data sources and do all kinds of conversions between those. And that has transferred into the Pro world, where you can now automate project management and all the items and components within your projects, including deep dives into the thousands of geoprocessing tools that are available in the desktop software. The API for Python was written for something fundamentally different. It was designed to work with your WebGIS organizations and the services that are published within there. So it was designed with the client-server request response architecture in mind. And so with that, you can do all kinds of analysis within the API for Python on your web services. And it gives you full capabilities for managing and administering your WebGIS in addition to all your data science and geoprocessing workflows. So these two libraries are complementary. They do not cancel each other out. They work together so that it gives you a comprehensive way of managing and blending file-based sources with web layers and integrating the functionality of the two. There's some overlap, but each library does have things that only can be accomplished within them. So they work together. How we deliver Python to you. With ArcGIS Pro, right, you install ArcGIS Pro, Python is installed. And in addition, there is a Python package management utility installed called Conda. And with that, Conda works through setting up environments on your system. Environments are a fancy word for directory paths that isolate libraries and dependencies from each other. And so with ArcGIS Pro, it's installed, and a default environment is created called ArcGIS Pro-Py 3, which includes the API for Python, ArcPy, and a couple hundred scientific libraries and other management libraries with Python. And then you can use Pro or other utilities to create and set up your own environments based on that environment so that you can do all kinds of development that require certain packages and you don't interfere with anything else. ArcGIS Online, when you access notebooks in there, Python's delivered to you through two different runtimes. There's a standard runtime that includes the Python API and 500 or so Python libraries, and there's an advanced runtime that includes all those same libraries plus ArcPy, so allowing you to get at your file system. ArcGIS Enterprise, if you install that and then license a notebook server component with your installation, those same runtimes are available in your on-premise ArcGIS Enterprise environment through those runtimes with similar sets of Python libraries, and then the standard including the API for Python, the advanced including ArcPy. And so what this means is that Python is here, there, and everywhere across the platform. You can set up models with Pro and I get at the Python code behind it, and you can use the Python analysis window in Pro to write code. You also have notebooks available to you in Pro, Online, and Enterprise where those runtimes are available. And if you don't have any of those, you can set up the API for Python with the Anaconda Python package management system and run a standalone Jupyter server on your local machine and run it in Jupyter notebooks. Then you can also use all your favorite IDEs to write standard scripts. We show a lot of notebooks in our presentations, but you don't have to use notebooks to get at these libraries. You can use standard scripts as well. And then with Enterprise and Online, you can schedule your notebooks and publish web tools. So all those are avenues through which you have the ability to automate. So enough talking. I'm going to turn it over to Nick, and he can show you some stuff.
All right. Thank you, John. So I'm going to take about maybe 15 minutes to try to cover some of the some of the points that John showed on his slides, and actually walk you through a recent project that I've done that I think uses a lot of these different strategies for scripting and automating, and it kind of just organically happened for me. So hopefully, when I show you how these strategies helped me, they could maybe help you in some of your work. So let me just set the context for what I'm going to do here. So I guess I would consider myself sort of a retired person who spent some time in academia, and so I still kind of keep my eyes on research papers. And I came across this one a couple years ago that I thought was interesting. And in the spirit of science and reading someone's science and trying to reproduce it and build upon it, I was like, well, I liked this paper, so I'm going to try to replicate the study that they did. And so basically the goal here is to take a whole bunch of precipitation data for a long time series and create a map of the US where you have these different regions we'll call them climate regions. So for example, in the Northwest, this is all similar climate. In the West, it's all similar climate, and these kind of big polygons of climate regions. Now, this map right here is showing hand-drawn climate regions from back in the 1990s. And you could pretty much see that these regions follow state boundaries. But if you look at a long time series of precipitation data, you'll note that precipitation and the patterns of it don't follow state boundaries or county boundaries or any kind of boundaries, right? So if you look in the Northwest, precipitation, obviously there's a large amount of variability over a long time series, and it doesn't really adhere to that nice grouping of 3 states essentially. So my goal is to create a new map of precipitation regions based on a long time series of data. So what I'm going to start with today is I'll start off with sort of what my input data set is. So this is a gridded point data set. You can see that it extends across the entire US. And each one of these grid points has a number of different pieces of information associated with it. In fact, it has about 16 different variables about all kinds of different measurements of precipitation, like the total amount of precipitation that occurred at a location for a season or for a seasonal average, how many days it rained on average over 30 years, and some measurements of variability. Doesn't really matter here, just remember that there's like 16 different measurements of precipitation for each one of these dots. And these dots are about 4 kilometers apart from one another. So that's my input. So how am I going to go from this to a nice pretty map of precipitation regions? Well, that's where all this scripting and automation came in. So I'll walk you through kind of my thought process. So first off, I'm in a notebook. It's a Jupyter notebook, and this is directly in ArcGIS Pro. Notebooks are built into ArcGIS Pro. You can add them, you can create new ones, you can manage them here. And so my sort of IDE of choice right now will be the notebook. And so with any Python script, the first thing you're going to want to be doing is importing your libraries of choice. And so John just mentioned to you the 2 ArcGIS Python libraries. ArcPy, which is the geoprocessing framework, and the ArcGIS API for Python, which I'm going to use for kind of a specific purpose here. But you'll also note that I'm importing a library called Pandas. This is by far probably the most popular open source Python library for working with tabular data, for adding columns, for cleaning data, for wrangling it, for managing it. So immediately, like, I'm sort of stepping in and out of ArcGIS here. I'm going to be doing some GIS, I'm going to be doing some open source Python, all within kind of the same notebook. And so the first thing that I need to do is go from this 4 kilometer by 4 kilometer grid to a grid of 16 kilometers by 16 kilometers, but maintain all 16 of those precipitation variables. So I'm doing like an aggregation, going from really tiny points to larger points. And the purpose here is to essentially remove some of the noise that could occur at a very granular level and sort of generalize to a more coarse level, which is going to benefit me later on in my process. But this is what I need to do, go from 4 kilometers to 16 and maintain all and maintain all of my precipitation variables. So I kind of thought to myself, well, what are the tools in GIS that would help me do this? And I realized that the first thing I would need to do is convert all these points to rasters, so points to pixels. And here, I could actually specify a cell size, which is larger than 4 kilometers by 4 kilometers. So I have coarsened my data set. But then I needed to go back to points because I go from a gridded point data set to a larger gridded point data set. And then I needed to use a tool to change some field names, do some renaming and cleaning. So I was like, all right, that's fine. I could run these 3 tools. I could go into the toolbox here, and I could search for point to raster, and I could input my precipitation data set, 4 kilometers. I could choose one attribute, the fall frequency of precipitation, create an output raster data set the cell size to something larger, and click run. That's fine. That's one variable, that's one tool. However, I need to do this for the next variable and the next variable and the next variable and 15 times. And I also then need to convert those back to points 15 times, and I need to rename some fields 15 times. So a total of 16 for 16 precipitation variables. So I thought to myself, well, there's got to be a better way than running these 48 tools by hand. So my natural thought was, well, in ArcGIS Pro, one way to do automation is through this thing called ModelBuilder. And so, has anybody in this room used ModelBuilder? Yay, a lot of people have. Okay, so this will be a review. Maybe you'll pick up a tip or a trick here. So obviously I'm running 3 tools in sequence. So I go into ModelBuilder, I add point to raster, I add raster to point, I add alter field, and I can now run these in sequence. But one of the nice things about ModelBuilder is while you're actually building models, whether it's for an input data set or whether it's for certain parameters of tools, I could actually go in and I can choose, see this little option for parameter? When you check on this option for parameter in ModelBuilder, it adds this little P above whatever you choose to add this on. So in this case, I'm making the input gridded data set a parameter. I'm making the choice of which precipitation variable to use a parameter. I'm making the cell size of the next raster that's created a parameter, and so on and so forth, which also includes the output gridded data set. So you see these little P's. When I save this model and I actually look at it in the toolbox, by saving this model, what do I have here? Batch aggregation. Yeah, here we go. Nope, sorry, wrong one. Yeah, here we go. Here's my aggregation tool that you're looking at. These little P's essentially expose all of those inputs as parameters in a geoprocessing tool. So now I basically have all 3 of these steps in ModelBuilder exposed as one user interface, just like if you were to open the buffer tool or the point to raster tool or any of the other 2,000 that are available to you. So input gridded data set, choose my variable, choose my cell size, and as I kind of go down this list, I'm actually picking at parameters from the other additional tools. Okay, so it's like 3 in 1 right here. Now that's great. I got 3 in 1, I have 16 variables. I could run this 16 times, but I still wasn't happy with having to run this tool 16 times. So I was like, well, there's got to be a better way to do this. So let's go back to our notebook. And actually, while we're kind of going through this, as far as strategies go, I heard a conversation in the first row here before, this notion of pseudocode, which is basically, you'll see that pretty much every line of code that I have a little note to myself that's commented out that tells me what that line of code is doing. And it's even a great way, if you kind of like conceptualize what your steps might be, you could write these little comments in the pseudocode that kind of walk you through and help you figure out what steps you need to take before you actually have to start writing code. The other thing, again, I think that's a good strategy to keep in mind with regards to using notebooks. In a notebook cell, you'll see here that this one actually is labeled as a markdown cell as opposed to a code cell. So because it's a markdown cell, I could add in this image. I could add in this graphic here that's showing my tools. I could go into here and I could add a new cell and I could say to myself, like, remember to mention this now, right? And so as I'm going through my notebook, I have this little note to myself. So I think pseudocode and markdown is a good way to keep your own sort of thoughts together, as well as if I were to share this notebook with John or with anybody in the room here, they would see, okay, well now he's reading in his input data, he's got his input data set, and whatever other code that I use here. All right, so we're back in the notebook. So all I'm gonna do is use ArcPy to point to my geodatabase, and I'm going to pull in the file, which is that 4x4 kilometer gridded data set. So run the cell. Now, I need to figure out how I'm going to take this ModelBuilder model and how I'm going to iterate and run that consistently using Python. So I'm going to use an ArcPy function called list fields, and this is basically something called a list comprehension. Think of it as sort of like a more efficient way to write a for loop. So I'm saying, all right, so for all of the fields in this input feature class, tell me how many I have, and give me the list of the fields. So let's run this cell. In that feature class, I have 21 fields, and of course, it gives me a list of all the fields. And I'm interested in all of these kind of 16 precipitation variables here. I don't really need the object ID, I don't need the coordinates, I don't need the X and Y coordinate. So in a cell below this, I've created another list that contains just those 16 that I'm interested in. Have a look at that list. And I have a little for loop here to print them out. So keep in mind what I have going here. It's a simple little for loop where it's saying for each variable in this list of 16, just print the name. But this little simple for loop is going to come in handy for my script. So let's add a new cell here and let's go back to this aggregation tool. So again, I need to figure out a way to automate this particular tool right here. So one of the nice things about geoprocessing tools, whether they come with Pro or whether you build them like I did, if you go down to this little run button, you'll see a little option here to copy the Python command. So I'm going to click this, and I'm going to go back to my cell and paste it. And so this automatically pulls it basically like turns whatever all this is into Python syntax. Okay, so like I immediately have the Python version of this tool. I've imported the toolbox. It's my custom tool, and it's got all my parameters. The input data set, this variable that I chose, the raster cell size, et cetera, et cetera. So what I've done below this is essentially taken this aggregation tool, and let's go through this cell real quick here. So remember, this is all the syntax for my aggregation tool. But what I've done is I've actually dropped this inside of a for loop. And remember, the variable list has a total of 16 precipitation variables in it. So what this is basically saying is for each of the 16 precipitation variables, input that gridded data set and run this tool for variable number 1 and variable number 2 and variable number 3, etc. And name all of the outputs, the name of the input variable, plus a little bit of syntax. So you see what's going on here. For each of the 16 variables, run this tool on variable 1, produce an output. Run the tool on variable 2, produce an output. And you can see here, in the interest of time, I'm not going to run this, but it took 3 minutes. So that would probably have been a lot shorter for me than going into the tool, filling out the parameters, running it, waiting for it to go. Going into the tool, running the parameters, waiting for it. And if I were to do this again, I'd just input the data, run the for loop, and the tool runs 16 times. So it's just kind of combining a little bit of these different elements with general Python principles to automate some of your work. So let's go back to our map and let's have a look to see what this looks like. It basically gave me 16 feature classes. So let's look at one of these here. Oops. And so if and note, 16 feature classes at a much coarser resolution. The green dots are at the 16 kilometer resolution. The blue dots are at the original 4 kilometer resolution. So it's a much smaller data set, but if I click on one of the points, you'll note here that each one of these 16 only has the one precipitation variable. So it's like I have 16 variables in 16 data sets. How do I get this all into one data set? Each one of these has a value, and it's got a point ID. And the point ID is going to be a unique identifier for every single point. So if you have multiple data sets with the same schema, and not only the same schema, but also the same unique identifier, you can join them together. And so my goal is to have all 16 of these in one table. So here's another option or another opportunity to automate. I could go in and I could say run join field, and I could open this tool and I could put in the first table, and then I could choose the point ID and I could put in the second table, and I could use the point ID and I could run the join. But of course I have to do this 16 times. So this is something that I think that maybe is not super popular or very much aware of, but anytime you go to a geoprocessing tool, you can right click on it and you have the option to batch, run that tool in batch mode. And I think that this potentially could be a big time saver. So in my case, I'm gonna run that join field tool in batch mode, and I could choose which parameter I want to batch, and in my case, it's gonna be the join table. So I'll click next here. So in this case, my input table would be, let's say I pick one of the 16 feature classes. Point ID is the input. And here, the batch join table, I'm simply gonna go in here and I'm gonna grab the rest of them, drag them in, point to the fact that they all have a point ID unique identifier, and then essentially click run. So you see what's happening here. This is taking one input table and I'm successively joining 15 more tables to it. And I'm not running that tool 15 times because I'm running it in batch mode. So I think that this is also a nice strategy to be aware of when it comes to just automating simple tasks in Pro. All right, so in cooking show fashion, let's get to the final data set here. So I went from a 4 kilometer by 4 kilometer data set to a 16 kilometer by 16 kilometer data set that when I click on one of these points, I have all 16 of my variables appended to it. So I'm ready to go. All right, let's go back to our code here. And now it's time to actually think about how am I going to create these clusters. So the purpose of this session isn't to talk about, kind of the analytics, but I do want to highlight just a few things here. So I'm reading in this data. The first thing I'm going to do is run a geoprocessing tool called dimension reduction. It uses a machine learning technique called principal components analysis. And the idea here is to take a data set with a lot of dimensions, a lot of columns, and reduce it down to a data set with many less columns, but those 3 dimensions retain as much of the sort of information about the data as in the 8 dimensions. It's a really popular machine learning technique. So just like I did with the ModelBuilder tool, I essentially went into the dimension reduction tool, I parameterized it, I copied the ArcPy syntax for it, so it's now Python code, it's in my notebook. I ran this tool. It created a new data set where basically the 16 variables, the 16 components were reduced down to 3. And in just those 3, I still retain about 80% of the information, which is good for me. So I have kind of a much more condensed data set. And here is, I think, where also being able to, kind of like what John said about the Python story and the fact that there's Python in ArcGIS and through notebooks and through these different APIs, you could actually hook into the entire open source Python ecosystem. So I have another cell here where I'm saying, well, now it's time to go out and grab something that isn't in ArcGIS. So I have some libraries here for plotting. I'm going to call a library here called NumPy, which is one of the probably most powerful and popular Python libraries for scientific computing, basically doing mathematical computations. And I'm going to actually pull in another library here called scikit-learn, which is a very popular machine learning library that does a whole bunch of techniques that ArcGIS does, but also that ArcGIS doesn't. So there's a particular clustering algorithm that I want. Now, the data format that I need to use for scikit-learn is actually something called a NumPy array. So here, I'm going to leverage the ArcGIS API for Python to convert my geospatial data, my feature class. I'm going to convert that to a pandas data frame. And in this case, it's actually something called a spatially enabled data frame. So you can see here that once this runs, it contains all of my precipitation variables, but it's in, as well as all the principal components, but it's in a pandas data frame format, and it has a geometry field. So it's a spatially enabled pandas data frame. Because I'm in a pandas data frame, it's easy to convert to a NumPy array. So here I'm just basically converting the pandas data frame to a NumPy array, calling specific columns. So I have an array. Array is the input that's needed for the clustering algorithm that I need. So I'm basically saying, all right, take these 3 principal components, give me 13 clusters using a certain type of function to actually understand the clustering, and a certain metric for distance. Doesn't matter what they are, but the point is that this is my GIS data that I've now read into a Python format and a friendly format for using scikit-learn. So I could basically create the clusters. I'm now saying, all right, in my data frame, create for me a new column that appends one of 13 clusters to it. And if we look here at the table, it's the same pandas data frame, but now I have a column that tells me which of the clusters it belongs to. So it's like I reached out to Python to do something that wasn't available in ArcGIS, appended that new information to my GIS data, and then I can use, again, the ArcGIS API for Python to write the spatially enabled data frame to a feature class in my geodatabase, and there it is, okay? So now, going back to the map, I can look here, and I'm actually looking at the results on the map here. And so each one of these points now has an attribute appended to it, which signifies one of those 13 clusters created by the scikit-learn algorithm. Now, there's one more thing that I want to kind of add here. And what you just saw was obviously, me showing you all this Python code, and I was actually running the clustering algorithm from within the notebook, and you're actually seeing the syntax there. But what if I was interested in having a much easier user experience to run this clustering tool, or maybe I wanted to actually give this clustering tool to John or to any of you so you can use it? So bottom line, what I want here is to be able to have a geoprocessing tool that does this clustering for me, that behaves just like any other geoprocessing tool. So the way that I've done that is in the toolboxes, I've actually created a new Python toolbox. And so when you create a new Python toolbox and you save it somewhere, call it test, save, what it will automatically do is create this script for you. And if you look to edit this, it actually kind of creates all of these classes for you, where, for example, like I could go in here and I could say, Nick's new clustering, right? And I could save this, and I should, I believe, refresh this toolbox, and it will have renamed this tool, and I could go in and edit this syntax again, and I could start to actually build a tool from scratch, a Python tool from scratch, using kind of this pre-written syntax already for you. So let me actually go up and open this. I'm going to input my one layer here. I'm going to choose analysis variables, which will be the first 3 principal components. I'll choose one of my distance metrics. And remember, all this is scikit-learn in the background. This is using an open source Python library. Set 13 clusters, and I'm going to click run. So behind the scenes, it's converting to spatially enabled data frame, it's running the clustering, et cetera. But let me just walk you through here. What I've actually done is used the Python toolbox and the code that it begins to write for me, and I'm creating my own parameters. I'm saying I want my input feature layer to be of certain data type, require it. I want analysis variables to be an input. I want the different distance metrics to be an input, et cetera, et cetera. So I define my parameters, and I go in here and I import all the libraries I need from the open source community. I've even added myself messages as the tool runs, and I basically then use the ArcPy syntax for creating this geoprocessing tool to say, all right, your first parameter is your input feature layer. Your second parameter is your analysis variables, and I have all the code. So I'm basically saying, all right, so my first parameter in the tool is the input feature layer. The first thing that happens is it gets converted to a spatially enabled data frame, and that's the input. So I'm creating essentially a custom Python tool here that runs all of that scikit-learn code to do the clustering. And now this tool is completed, and it has added to the map, and you could see here that that is the output result there. So that was sort of a whole bunch of different information, but I think hopefully what it highlighted is that within ArcGIS, whether it's ModelBuilder, whether it's a notebook, whether it's Python, there's a lot of ways to kind of connect all these pieces and do it all in one place, and use it to automate and use it to sort of make your life easier as you go through. So I'll pass it to John. I think we'll talk about more automation.
There's a quiz on that workflow before you leave this room, so I hope you were paying attention.
There's a blog that I'll share with you that walks through it.
And the other major takeaway is be careful of your conversations in the front row because we are listening. Okay, so what I'm gonna do is show you some workflows about, that are just gonna sort of compare some things you would do in the web interface and how you would translate that into API for Python speak. So I've got a notebook here, and I've set up my online environment with some files that I want to use to update my data. Like, so you could make this workflow fairly complicated if you went out and pulled data down from the internet and we're just constantly updating your data. But I've downloaded some files that I'm gonna use to update the source of a hosted feature layer in my environment. So here's my notebook, and it accesses the, searches for and accesses the a feature layer, hosted feature layer, and then it just queries a couple features. This data is about air quality, so I'm gonna print out some metrics for a couple different site stations that are part of this data set. And then the thing to note here, I'm gonna insert a blank notebook cell, an empty cell in the notebook, and I'm gonna use the notebook functionality here within the view menu called tags. When I enable that, I'm gonna tag this cell with the phrase injected dash parameters. I'm gonna show you in a minute what that means and what happens when you do that. And then what I'm going to do is I've got the code here to overwrite the source of my feature layer. So in effect, updating my data. And I'm using a parameter called file path and a number variable to change the name of the file that I use. And we're gonna see how that works in just a minute. And then I just update my data source, and then I print out those same feature values to make sure that this thing is actually happening, right? And so what you can do this in the web interface through this create task modal, where you can enter the title of the of the task, and then you can enter parameters here. I should learn about typing in public. And you add your parameters here, and then you can set up a schedule to run this notebook at whatever time frames and whatever intervals you so choose, right? But I'm not going to do that here because I already did that with the Python API, right? So it's the syntax for doing that is to get that notebook item, and then there is a tasks property on the user object, which returns to you a task manager object, which then you can use to create a task, right, whose parameters are the notebook item itself. It uses a utility called cron, which, if I understand it, is a Unix world utility for scheduling regular tasks. And so each of these, there's a very specific syntax for cron scheduling. There's a grillion resources for it out. Google is your friend in this case. And just to make it ultra confusing, it uses UTC values, so you have to translate when you set things up. So I set this to run at 2 o'clock Pacific. I have no idea what the time value is for you wherever you live, right? So this is ran at 2 o'clock today, right? It created a task called this, and here's where I enter the parameters that I want to run in that notebook. And like I said, I ran this before we all gathered here today, and I'm gonna go out and show you that task was created here on that notebook item. And when I go and look at the details of it, I can see that we had a run that succeeded, right, which is the goal. So let's look at what happened in that notebook. Okay, so I accessed my feature layer. Like I said, the first thing I do is just print some metrics, in this case, ozone and particulate matter. And then you see that cell that was empty, where I had injected parameters, tagged that cell, the parameters from the script got inserted into this notebook when the task ran. So that's how you can automate the process of running really complicated workflows in notebooks that and insert different parameters there. And so what it did was update the data source for that. And if we verify that, let's see. So my values here were 11 and 16.8. Now they're 11, 16.1. I can be pretty confident my tool ran, and now my data is updating with the appropriate source. Okay? So that is how you can, another workflow for notebooks, something you can do with notebooks. I think this might be valuable for application developers in particular, right? This execute notebook method does the exact same thing, except it doesn't schedule it, just runs it right away, right? And I also ran this before we met here. And so what we're gonna go do is go look at the notebook itself and see if it actually, this ran as well, updating, executing that notebook. So when I go and open the notebook, we're going to want to see whether whether the parameters updated to use my second data source, so that I know that when I execute notebooks, things are working. And if I say I develop an application where this is running, you just click a button and it runs this behind the scenes. Again, this is a way for you to automate things within applications. So as we're waiting for this to draw, we're going to come back to it, right? And I'm going to show you another workflow that translating publishing of file-based data sources into a web service, right? So Something that I think people do one thing that you do pretty regularly when you're publishing data is you're accessing data on your system and publishing it. So here I have a CSV file of cities in Denmark, and the first menu item you get in the web browser is it's telling you it's going to add this CSV item, and do you want to publish it as well as a feature layer, as a web service. So if I say yes, then the next thing is I go and this is analyzing that CSV, but then you fill out the rest of the dialog, and that's how you publish the data, right? I'm not going to do that in here because I've already set up a notebook to do the same thing. So how we translate that into Python API is to connect to the organization and then set up a path to where my file resource is, and set up a variable to my file itself. And then you are going to add this into your WebGIS. You're going to add the item with this code here. You first set up the properties of the item, then you add it into your WebGIS. So we see we've got the CSV item added, and call the publish method, and now you have the feature layer. And we're verifying this through drawing, right? Okay, so now we're going to backtrack, right? So my notebook finally drew up. What we wanted to verify was that when we executed the notebook, instead of using the 1 variable as where we scheduled it, it used the variable 2 here and updated the file source again through that execute notebook code, which we see that it did. And what we want to verify, did my values change? 11.16.1, 11.16.8, it changed. So this is a way you can automate updating data sources at the web level. Okay, so we saw also a workflow of how you can automate the process of publishing data. Now, I've also run a workflow that you can't accomplish through the web interface. This is something that you can do within the Python API. And this is a straightforward workflow of cloning a web map that has feature layers within it as the operational layers. You can clone that from one organizational deployment to another. So let's see how we do that. So first we connect to our 2 organizations, and then we get the web map we want to clone. And I use the Python API's web map object to then print some information out about the hosted layers within that web map. In particular, the way I verify this is this component of the URL path, the one right after the I think it's called the net scheme, right after that first component of your path is your organization's ID, right, when you're talking about ArcGIS Online. So this web map is using a feature layer hosted in this particular organization. This feature service has 3 layers, and it's using another feature service in addition to that. And then I'm just saying, okay, this data is not in my target organization, so this is how I'm going to clone it. So I just I insert the web map into the items variable and stick it in a folder if I so choose. And what I can see is that the web map was cloned along with the 2 feature services that were included as part of that web map. And here I am just verifying that now we see my organization ID is different. This data now lives in my target organization. So that is a workflow for cloning. That is something that we get asked about a lot. That's how you can get data from a development environment to production, or development to staging, whatever. You can clone all kinds of items that way. Done.
So your first example there for the scheduling.
Yes.
So that was using code in a notebook to automate a task, which was a data update. But then you also use code to automate the running of that notebook on a schedule. This is kind of like two pieces of automation.
Well, it's two pieces of automation. The first workflow created a task which runs on a scheduling interval that you enter in through that cron syntax. There's ways to develop that. This second workflow, executing a notebook, happens real time.
Right. Okay.
So that's just a way that, like I think the best use of that is like if you're developing applications and you've got a button in there, this code can run behind the scenes to execute notebooks for whatever your purposes are. You're the domain people that are developing all this stuff. So that's what you can do with that particular functionality, one use of it. So yes, those are the demos that we have set up here. And lastly, let's show you there are some additional resources. Crap. You knew a flub was coming. Okay, so some additional resources for you to take a look at. We mentioned the runtimes and how Python is delivered to you, and that there are hundreds of different libraries. There are manifest lists of everything that's included if you want to go out there and look for these. And in addition, there is a world of code samples out in our help documentation, both in the ArcPy, the Pro tool reference has code snippets galore, and we have at the developers.arcgis.com/Python site, there are guides, sample notebooks, and an API reference document that has all kinds of examples of how you use the code. So in conclusion, this was awesome, right? So, okay, Python is everywhere in the platform, right? You can use it, it's in all the products, right? And it's very accessible throughout the platform, and you can combine all kinds of open source Python code with your trusty Esri GIS functionality, and the world is your oyster, right? So if you're into social networking, here you go. And lastly, fill out a survey. I can tell you the answer to every question is excellent. So if that's not your answer, don't go to this website.
Thank you. Enjoy the rest of the conference.
Okay, yeah. Questions? Or do we still have time for questions? Yeah, we have 8 minutes or so for questions. Yeah, I think I saw you first. Have you?
Do you guys have any examples of this stuff in the publishing workflow that kind of involves things that aren't CSV files, like kind of like polygons? I feel like that's like for a lot of publishing.
Yeah, do we have examples of workflows where we're publishing things that are not CSV files? Yes, we do. At that resource that I mentioned, developers.arcgis.com/Python. Right? Here is that documentation, and if you go into the samples tab, there's a list of content published. There's a content publishers heading in the table of contents here. There are examples for publishing a few different types of data sets as feature layers, including shapefiles, CSVs. What I can tell you, the syntax is the same no matter what your data source is, right? If you're publishing from a shapefile or a file geodatabase or a CSV, the code looks the same in the sense that you set up the item properties, you add it into the WebGIS, and then you call the publish method on the result of that add method. You just have to make sure that when you are adding an item, that when you set the item properties, the title and the tag are required, or title and the type. So, but the syntax looks the same regardless of what the data source is. That's different than overwriting. That's publishing is adding it, right, and creating something. Overwriting is different, where you use an overwrite method on, it depends on what the object is, but overwrites is where you then would want to use a different file as the source for that item. Yes, you had your hand up here.
In the web map cloning, is there I could just search through the API.
Yeah, but you wouldn't want to do that.
Get the conversation going. Is there a nice method, built-in method for replacing, so like if you clone a web map to another portal, and replacing URLs of like hosted featured layers?
I would say, so the question is when you're cloning a web map, like the workflow that I showed cloned the actual content of the web map, the feature layers itself. What I'm hearing your question as, is there a way when you clone, if you have data already in your target organization that you want to use and sort of remap your web map operational layers to use pre-existing content? Yeah. Yes, there is a way to do that. In the clone items method, there is a parameter called item mapping. And what that is a dictionary. So you would say you cloned your web map, you would use the item mapping parameter to, the key of the dictionary would be the item ID of the source feature layer. The item ID, the value is the item ID of the target layer you want to use. And then when you create, then the web map is cloned, and then it will behind the scenes remap. It'll swizzle is the term they use, right? It'll rewire the JSON of the web map to use the item IDs of the pre-existing content.
Okay, great. Yeah, I was just wondering if you have to get into, if there was a method already built, or if you have to get into like, what is it called, beautiful soup?
Yeah, no, you don't have, not with web maps, right? There are, with some of the more complicated item types like dashboards and story maps and survey 123 items where the actual content is stored very differently than something like a web map. There are some times where you have to go in and remap values and update those items by hand versus just cloning.
Does it work, do you expect it, or is it expected to work similar, the same for feature layers or for views of those feature layers?
So the question is, will cloning work the same with feature layers versus views of those feature layers? I think I would have to test it, but if you clone a view, it's going to clone the underlying feature layer and recreate the view in the target.
And then if the web map is using both layers from the hosted feature layer and from the view of it, they should both update accordingly as long as you use the item mapping.
I'm going to say that should is the key word there, but yes, right? Like written in pencil. So yeah, I'd have to try that. I don't know that off the top of my head. You know, come to the island, or if you've got code that does that, we could take a look at it. But I think if you hit, yeah, layers can get tricky when you've got two layers referencing the same source. Things can get tricky behind the scenes. I don't know if clone fumbles around with it the way some other functionality may. Yes, go ahead. Sorry. I'm sorry? Oh, which island are we at? It's the Python island, ArcGIS API for Python. When you go through the first set of doors into the showcase, it's a straight shot on your right.
So you're saying that if you use this cloning method, it will clone it from one org to another org and repoint the map, the featured layers to those within the new org?
The question she's saying, what I'm saying is that when you clone things, when you clone an item, it will take information from the source item and remap it to the target item if you set up the parameters in such a way to do so. And it depends on the item type.
And I assume that will function for dashboards, et cetera, not.
No, it will not function that way for dashboards. Dashboards store items very differently than do web maps or feature layers. There is a way to do it with dashboards, and there is a document out, there's a guide document that goes through dashboards. And I would recommend that you attend the cloning session tomorrow at 1 o'clock, or the content migration session at 1 o'clock. You'll get to hear me again, so if that doesn't bother you too much. But content management, there is a cloning and troubleshooting complex items, which goes through dashboards and story maps and explains why item mapping doesn't work for them. There's the architecture behind the scenes is different, but there is a way to then clone dashboards and rewire it.
One more, and then I think we need to wrap up in this room, but I'll go right to the back here.
In your demo, you created a Python toolbox, the older format, PYT. Is there, should we be using ATBX versus PYT, or does it matter? Is there functional differences?
That's a good question. I mean, this was a sort of a personal preference for me. This is the way that I did it. I would recommend, there's an ArcPy island right near where John was, and there's folks in the ArcPy team that would be able to answer that question and what the best practice is.
Your question is there a difference between the original Arc toolbox, the .atbx toolbox, versus the .pyt toolbox? I'm just kind of repeating that question. I don't know the definitive answer, but
yeah, they'll know over there though.
yeah, I just think the .pyt file is written exclusively in Python, where the ATBX is binary in some way. So,
yeah.
But whether the functionality differs, I don't know. Yeah, talk to the guys at the.
Right, and if I recall, so when I created that new PYT toolbox, it had already sort of populated all of these classes and functions, and that made it easier for me to kind of do my thing within that format. So that template I found to be helpful, but you should verify with those guys there. Okay. So I think we probably should wrap up, but we could sort of walk and talk, and also we'll be working at the islands if you have additional
Thank you very
questions.
much
Thank you very much
for
coming.
your time. Have a good rest of the conference.